Good day everyone, I am Shane Marie S. Coronel and this is my thesis presentation, Process Rheum palmatum L roots via various techniques, enhancement of traditional medicine agent against pathogenic Staphylococcus aureus. So studies on natural compounds derived from plants, animals, fungi, and bacteria have been expanding in recent years, driven by the search for alternative, cost-effective, and safe treatments for complex health issues. Natural products, especially those used in traditional medicine, have shown significant therapeutic potential across a range of conditions, influencing the development of conventional medicines including drugs for cancer, high blood, and migraines. As we all know, China has a rich heritage of traditional medicine that has been practiced for millennia, rooted in the principles of traditional Chinese medicine. Originating over 3,000 years ago during the Zhou dynasty, TCM stands as one of the oldest and most enduring systems of natural medicine, continuing to play a vital role in the healthcare across Asia today. The effectiveness and safety of traditional Chinese medicine depend heavily on the precise processing techniques used to prepare its medicinal materials. Methods such as high-pressure steaming, stir-frying, and the addition of excipients like vinegar and honey not only enhance the therapeutic properties of herbs, but also minimize potential toxicity. One of the most significant herbs in TCM is Rheum palmatum L, valued for treating and addressing impaired blood circulation, laxative property, and variety of pharmacological effects including antibacterial activity against both gram-negative and gram-positive bacteria. Its active compounds are rein, aloemodin, crisophanol, imodin, and fission. However, R palmatum also has a toxic effects, particularly on the liver and kidneys, and can cause digestive issues like diarrhea and constipation. So proper dosage and control and processing methods can balance these dual effects, mitigating risks. Multiple sources indicate that the general effect of heating R. palmatum is said to degrade conjugated anthraquinones, which are the causes of diarrheal effects, and accelerate homeostasis through physical absorption. Liquid excipients like wine influences TCM composition. Wine, rich in bioactive compounds and antioxidants, enhances drug absorption by better blood circulation. On the other hand, vinegar addresses unpleasant odors in TCM and lessens side effects and toxicity. These processing methods are essential for maximizing the therapeutic benefits of R. palmatum while minimizing its toxic effects, ensuring that it remains a valuable component of TCM. By Chai examined the roots of R. palmatum and the different processing methods applied to the root. The previous study included assays and discussions on phytochemical content, antioxidant activity, HPLC analysis, MFC power density analysis, molecular docking, molecular dynamics, pharmacore modeling, and antiviral activity of the process samples. Building on this work, the current paper focuses on the antibacterial capabilities of R. palmatum roots processed through different methods. Specifically, it investigates the effectiveness of these process samples against a range of bacteria, including gram-positive strains, Bacillus thuringiensis and Staphylococcus aureus, and gram-negative strains, which are Pseudomonas aeruginosa, E. coli, and E. coli DH5 alpha. Additionally, the study aims to determine the optimal concentration of the process sample solution for antibacterial. Following the in vitro assays, an in silico analysis was conducted, specifically utilizing molecular docking to investigate the interaction between proteins found in target bacteria. Importantly, this research also aims to support the standardization of TCM by providing data that can help develop guidelines for processing methods. As TCM gains global attention, standardizing these processes becomes crucial to ensure consistent quality and safety. By establishing clear, uniform procedures for sourcing and processing, the TCM industry can improve quality assurance, build trust, and support its integration into modern healthcare as a reliable form of complementary and alternative medicine. The scope and limitations of this study examines the antibacterial properties only of the process Rheum palmatum using laboratory tests such as disk diffusion broth microdilution. The full range of bacteria that the samples could affect isn't known, limited bacterial species only, and the study focuses on certain compounds in Rheum palmatum and doesn't fully explore how they work together. Moving on to the methodology, we have the sample preparation, plant material. Our palmatum roots were obtained from a traditional Chinese medicine store located in Tainan City, Taiwan. The root samples underwent processing and extraction procedures as outlined in the article mentioned earlier. The table flashed on the screen illustrates the various processing methods employed on the plant roots extracted using water as solvent. Then we have optimization of test conditions. This diffusion assay was utilized for bacterial sensitivity and sample concentration. Bacterial sensitivity towards the process sample was determined using this diffusion assay. Both gram-positive and gram-negative bacteria were tested, applying appropriate conditions for each bacteria. The gram-negative bacteria included Pseudomonas aeruginosa, E. coli, and E. coli DH5 alpha, while the gram-positive bacteria included Bacillus turcoris and Staphylococcus aureus, and a yeast culture Candida albicans. The bacterium exhibiting the highest sensitivity was selected for subsequent testing. On the other hand, we have the disk diffusion assay to determine the sample concentration. The concentration of the 11 processed sample was evaluated by weighing 10 milligrams of the powdered samples and dissolving it in varying volumes of water. The 10 milligram sample was dissolved in 0.2 milliliters, 0.5, 0.8, and 1 milliliter. The solution was then adjusted to a final volume of 1 milliliter water solvent. And then we have antibacterial screening tests for this diffusion assay. Initially, bacterial culture were grown in nutrient broth with an adjusted inoculum size of approximately 10 to the 8 colony forming units per milliliter. And then the plant extracts were injected into 6 millimeter sterilized filter paper disc in doses of 50, 30, 20 in microliter with resulting concentrations of 0.5 milligrams, 0.3 milligrams, and 0.2 milligrams per disc. Positive controls were kanamycin and chloramphenicol, while the negative control is water. For the broth microdilution, we have to identify the MIC. The plant extracts initially in a stock solution concentration of 1 milligram per ml underwent a serial dilution by a factor of 2, generating concentrations from 5,000 to 9.8 micrograms per liter. The 96 well plates were then covered with aluminum foil and incubated at 37 degrees for 24 hours. After the in silico analysis, molecular docking of the proteins and ligands were carried out to CB-Dock2 simulation. Blind docking of the protein ligand were performed, which resulted in binding affinity scores. Highest binding scores in kcal per mole were taken into account and was described as the action towards target proteins of Staphylococcus aureus. Moreover, 2D protein ligand interaction was visualized through Discovery Studio Visualizer. And then data treatment. Data obtained in 3 trials were reported as means plus minus standard deviation, and statistical evaluations of one-way analysis of variance ANOVA were conducted to verify if there are significant differences between processing samples and positive and negative controls. Then we have the results and discussion. For optimization, further testing was conducted with other gram-positive and gram-negative bacteria, but no inhibition was observed. Hence, this experiment proceeded with using Staphylococcus aureus against process R. palmatum. For solution concentration, the final volume of the solvent that would dissolve the 10 milligrams powdered sample is 1 milliliter DD water, and the volumes of the solution injected onto the disc were 50, 30, and 20 microliters, garnering milligrams per disc values of 0.5, 0.3, and 0.2. For the antibacterial screening test, this diffusion assay, RP4 corresponding to the roots treated with high pressure steaming with wine showed the largest diameter of 11.67 millimeters. Based on the result of the ANOVA, there is a significant difference between the results of the process samples and the negative control, which is water, and the positive controls, which are kanamycin and chloramphenicol. For broth microdilution, post-incubation, the turbidity of the wells was examined to evaluate bacterial growth, with changes in the solution's cloudiness indicating the presence of bacteria. The results show that most process samples had MIC values greater than 1250, with RP4 and RP5 exhibiting MICs of 1250, while RP9, RP7, and RP10 had MICs equal and greater than 2500 micrograms per ml, respectively. For molecular docking analysis, it is worth mentioning that the previous study conducted HPLC analysis to identify the main anthraquinone in these samples. They found that cryptophanol and fission were absent in all water-extracted samples, while aloimodin and amodin appeared only in trace amount, and rhein was present in low concentration. Due to the limited detection of these anthraquinones, the study shifted to investigating other compounds that might contribute to antibacterial activity, now focusing on total phenol, total flavonoid and total polysaccharide content, and other anthraquinone derivatives. Given the circumstances, this study referred to literature identifying other biomarkers in our palmatum roots processed with wine steaming. The related study is this ultra-performance liquid chromatography quadruple time of flight, mass spectrometry, and multivariate statistical analysis to distinguish between raw and processed forms. They identified markers such as catechin glycopyranoside, gallic acid 3-O-glucoside, imodin 8-O-glucoside, and chrysophenol dimethyl ether, which belong to the phenol and flavonoid classes noted above. These markers will be used in silico analysis to examine their interaction with S. aureus proteins. Given the similar antibacterial mechanisms of these biomarkers, causing structural damage to bacterial membranes, reducing membrane fluidity, and inhibiting biofilm development, the study focused on surface proteins that facilitate adhesion, such as Staphylococcus aureus sortis A and clumping factor A. Molecular docking results indicated that the highest binding scores were against clumping factor A protein essential for bacterial adhesion. CLFA promotes adhesion by binding to fibrinogen, a liver-produced protein vital for blood clotting. By coating bacterial surfaces with fibrinogen molecules, CLFA prevents the immune system from recognizing and targeting the bacteria. In addition to the binding scores, the protein-ligand complexes showed hydrogen bonds, van der Waals interaction, and pi interaction, all contributing to the stability of the complex. The 2D diagram of this interaction is displayed in the screen. A recap of the results of the assay antibacterial screening test showed that RP4 exhibited the largest zone of inhibition among the 11 samples, while the molecular docking analysis showed that biomarkers in RP4 had strong affinities towards targeted proteins, comparable to kanamycin and chloramphenicol. However, there is an inconsistency with these results because despite these biomarkers showing high binding affinity and are very much comparable to the positive controls, the zone of inhibition produced by RP4 is significantly smaller than these positive controls. One possible explanation for this discrepancy is the lack of synergism. While individual compounds may exhibit strong binding affinities in docking studies, their combined interaction may not result in the enhanced antibacterial activity needed for effective inhibition. This could explain why RP4 showed weaker inhibition compared to control drugs despite its promising docking results. Most research on natural compounds synergism focuses on combination with antibiotics. There are studies on Rheum palmatum compounds showing synergism in non-glycosylated forms like gallic acid and catechin-specific ratios of 9:5 and 9:1. This means that the ratio is an important aspect of synergism. It is almost always dependent on the dose ratio of the combination tested. With this, the study concluded that among the bacteria tested, only Staphylococcus aureus is sensitive, and that high-pressure steaming with wine is the most effective method against this bacteria. The high binding affinities of RP4 ligands to CLFA suggest that antibacterial is due to the interaction with this protein, and that the reduced overall antibacterial effect may be due to the lack of synergism. This paper also recommends future studies to investigate the synergism between these markers and examining the post-treatment cell morphology of Staphylococcus aureus to provide additional insights on these mechanisms. Lastly, process samples should be tested against more types of pathogens to see their broader antibacterial activity. Again, this is Shane Maria's Coronel, and thank you for listening.